Roger.
Thank you.
We've raised favorite Minecraft background.
All righty, welcome everybody and those that are Minecraft players, including my kids and my husband. That's all they do on their spare time. Welcome to the APAC community call for May 6, 2020. Today we have, we're honored with one of our presenters, Dr. Anton, who will be speaking about the projects that they have going on there. And then after that, I will be showing you guys what the changes are to the CDM version 5.5. Okay. Let me see. Sorry, there's some background noise. I'm not too sure who it is, but I'm going to mute some of you guys just to make sure. There, background noise gone. So what's in Odyssey? What happened in Odyssey? Last week, we actually had a pretty cool event in Odyssey. We did a virtual networking session where we were invited to this farm. All of us virtually into this farm, and they had little areas set up for us that we can go in and chat with each other or chat on tables. I can't show you anything because they didn't record any of that. And that was a pretty cool idea. We may be looking at actually organizing something like that on this end, so that folks that are on this call here can have a chance to chat with each other and not just always listen to us talk or the presenters talk, right? Let you guys get together and just have a chat about what's going on amongst your groups and meet new people here, right? So that's what they did last week. Overall, there's still lots of papers that are going on. They also had working group updates from different working groups. So if you are interested in hearing about some of the different working groups and what they did, they would love to go ahead and visit the Odyssey network, or I'm sorry, Odyssey website. I actually did give an update about what's going on here on the Asia Pacific call after our APAC community call 2 weeks ago. And they, the global site is wonderfully impressed with all the stuff that's going on here. And actually, we may be inviting some of the regional leaders to actually speak at the Odyssey Global Community Call. Haven't figured out how to arrange that yet, but we would love to hear from you guys and the activities that are going on here directly. We may have to record some of them because it is at, I think, like 11 p.m. for those that are in China, 12 a.m. for Korea and Australia. I think that's like 1:30 a.m. your time. So not something you guys will probably want to attend in person, but we can look at doing recordings there, right? So those are kind of the activities between the two groups. So without any further ado, Dr. Anton, do you want to display your own screen, or would you like for me to display? So Dr. Anton is going to be speaking about Australia Real World's search infrastructure pilot.
Yeah, I'm happy to display if that's okay.
Okay. Yes, totally. Okay. Let me stop sharing. I think I stopped sharing. Yes.
Yep, you did. That's fine. Okay. Can you see the screen now?
Yep.
Oops. Okay. Okay. So my name's Anton van der Vicht. I'm a postdoctorate research fellow at Queensland University and working with Claire Sullivan and Guido Zuccon with a group called Empower, which is a collaboration between Queensland University and Queensland Health. So today I'm just going to give you a very brief update on just some of the work that we're doing that's relevant to the OMOP community that you may be of interest. Well, first of all, what's the purpose of Empower? I won't go through all of this. It was more to point out, really, Empower is a collaboration, as I said, and we're aiming to deliver capability to leverage the data from the EMR that we've got in Queensland Health. And that's for the obvious reasons for health service evaluation, observational cohort studies, and secondly, to build up and develop a world-class electronic phenobank. And so we're looking at using that so that we can do things like clinical decision support and real-time predictive analytics, etc. And I guess what's probably not very remarkable about this is that if you looked at any healthcare organisation around the world, or very many of them who are looking into utilising their EMR data, they would probably have a similar kind of objective as these ones, i.e. how can we really make use of the data that's sitting inside the EMR system. So in that sense, we're probably one amongst many. But then, of course, if you looked at the journey that each of these healthcare organisations might take, each one will probably take quite a different pathway in order to try and unlock the value inside their EMR. And so I just want to give you a little snippet into seeing how we're doing that at Queensland Health. Well, about Queensland Health, very briefly, we've got the largest and only statewide electronic medical record system across Australia. So that's amongst the other states. We're the only one. The database consists of over 6,000 tables and 100,000 fields of data, although of course, realistically, probably just several hundred tables are in active use. A lot of the other ones are internal and reference tables and things like that. But of course, the potential for secondary reuse of this data to improve clinical outcomes through targeted data access in things like dashboards and research and practice improvement is absolutely immense. But I guess like most other organisations who are trying to tap into those EMR systems, there's enormous challenges. And some of the specific ones that we've got, which I think would also occur elsewhere, first of all, because of the complexity of the database and because we have very limited expertise around that database, then accessing the data directly by non-technical staff is really not possible at all, outside, of course, of just pre-built reports. And identification of the desirable data, so the information that you might want for research and other purposes, is extremely slow and requires the support of experts. And the point 3 there, which is even for technical experts, selecting this desirable data is a slow and iterative process and prone to error and really requires rigorous manual validation. And that's because, you know, you're really trying to identify data that's getting collected at one end by clinicians and they're entering their data, but trying to track that through and back into the database is a very slow and difficult process. And then once you identify it in the database, of course, then you want to extract it with other information. And then each project to generate a data product, and by data product, I mean a thing like a dashboard or a research data set or a report, each project that we do is bespoke with little or no reuse across the disparate teams in Queensland Health. And finally, the provenance of the data on those data products. So if someone says, oh, okay, I like this dashboard, it's great, it's showing me lots of really good information, but how can I trust the information? What about this variable here? Where did that variable come from? So in order to try and identify the provenance of that data, it's very difficult to track back and find any sort of validated definition of what that data is. So these are some of, I guess, typical specific challenges for us, but I think they'd be quite typical for many healthcare organisations. So, ta-da! Of course, you've got your ready-made recipe for building research capability from EMRs, and I'm sure you're all getting very worried at this point, thinking, is he ever going to talk about OMOB? So I absolutely am, but I want to just reflect a little bit on this, and you might see down below there, I've got a link where I took this picture. I hope that was okay, but it's a very good picture of how these common data models work and how they can be used, etc. But I wanted to reflect on it with respect to the health organisation, and in particular our health organisation, as opposed to for researchers. It's very clear what the outcome is for researchers, but let's reflect a little bit more about healthcare organisations. And I've identified here a number of different points a number of different questions that I would like to address. For example, how do we integrate the architecture with other healthcare organisation data products? So in other words, I see down the end here, you've got collaborative research, and we're going to create some data sets that are of great use. But what about our own internal data products that we've got, reports and dashboards? How do these link in with the healthcare organisation into these other products out the end here for researchers? And it looks very much like we're using multiple systems here. Secondly, how do we understand the lineage of the data for the final data product? So over here, we've got our OMOP. We might have some standardized data tables, etc. And so it's a matter of understanding the lineage of how those data tables go all the way back into our IMR system, so where they're extracted from, whether or not any transformations occurred, and also what those definitions are. So each and every field that shows up over here in this OMOP database, what does that mean from a clinical perspective, and have we defined that and validated that definition? Thirdly, how do we reuse and build the artifacts? And this is a big question, I think, because at the moment we've got over here these common data models, so databases, etc., data tables, and we've got data sharing. We can build up machine learning models that might come up with predictive algorithms for clinicians. But then what happens then? We've done a research project, we've come up with this model. Can we reuse that model? Is that model findable anymore? Can we find it so that it's not just in that one research group, but actually for the Queensland Health, is that model available to maybe retailer for a similar task, but maybe slightly different data? And as you can see here, that's not readily obvious from this particular picture. Fourthly, can we reintegrate the outputs of research back into clinical workflows? And I know that this is a keen research topic, and you see lots of papers on this, which is how do you take the findings once you've got a model which you think is very good and it's going to be accurate enough and clinicians trust it, but how do we feed that back in so that clinicians incorporate that within the workflow? And at the moment, of course, each of these questions are typically answered in a bespoke manner. So you take that back and then you'd have to build something back here in your IMR to incorporate that back onto dashboards that you might be using for clinicians to use. And then how do you govern these processes? For a healthcare organisation like Queensland Health, that's a critical question around all the aspects of data security and access to data, and whether or not these data models that we're using are secure and safe. Okay, so we're addressing this in a number of different ways, and there's first of all a foundational layer, secondly a data selection layer, and then finally research models. In the foundational layer, we've built a product called Queensland Integrated Element Tracker, QIET. And in a nutshell, what it does is, a typical workflow is, first of all, we establish governance. So we enable the rights for people to edit different artifacts. By artifact, I mean things like dictionary definitions, so metadata that describes the data that we want to use. And we allow who can approve, and typically that will be governance groups, and also audit trails. Secondly, we have an area where you can create these dictionary definitions. So these are things like metadata around the variables that you might want to use from the system, the computed items, cohorts of patients, things like that. And once again, they need to be validated and approved. And then we've got an area where we allow models to be defined, and typically that's done by a technical person, and they link directly into the dictionary, so that we've got a data lineage between the data model and these dictionary definitions. And then finally, we define these data outputs, things like dashboards, reports, or research projects, so research data sets, for example. And finally, we look at a standardized process for commissioning data. So if you're going to put an analytical dashboard up that tracks data for clinicians to use in their everyday work, then we need to commission that by validating that what they're looking at is in fact what they expect to be looking at, and it's accurate. So, benefits of that foundational layer, well, they allow us to build and reuse knowledge. So all the metadata is constructed and searchable for future clinicians and researchers. So once again, once you've found that data item that you were looking for, then the next person can easily find it without having to go back to a custom project to actually find the data in the database. We can inherit knowledge, so you can build cohorts and then base those on prior cohorts. So if you've got a cohort of patients, of dialysis patients, for example, but you want to look at dialysis patients with who have had myocardial infarction, then you can base that new cohort on the prior cohort. You have data lineage, which is all the way from the data product, i.e. the dashboard or report, research data set, etc., through the data model and the data definitions. You've got dependency management, therefore, so that if you make a change to, say, how you extract data, then you can look at the impact of that on what data products are impacted. And you can also standardize the validation and commissioning of those data products. The second stage is around data selection, and this is really all about facilitating IMR data access. And in this step, really, there's three. So it's the concept, again, of selecting a cohort, selecting variables that you want to track against that cohort. You may want to do some transformation on those variables, and then that will create an extraction specification, and then that gets extracted. So the idea here is that you're trying to make it possible for non-experts, non-data people to be able to define the elements that they want, which patients, which variables for those patients, any data transformations, and we can derive some sort of extraction specification. In terms of the cohort, as I said there, you can search for existing cohorts. You can also use structured or unstructured data. So that means you can use clinical notes as an example of unstructured data, where you might want to try and pick people with surgical site complications as an example. Or you can pick them via structured data, for example, patient's age or their diagnosis and things like that. You can select the variables, so from different domains. So we've made it easy to find variables in particular buckets, if you like, so that it makes it more straightforward for clinicians or researchers to understand where to go to find data. We also put the screenshots there of where the data is collected in the system. And then, as I mentioned, you can transform those data sets. So the benefits of this data selection layer is that it enables non-experts to identify the data that they want, and therefore the extraction method that's needed. We can reuse cohorts and data sets. So once a cohort's defined and another research group wants to use the same cohort, they can reuse it. And we can identify cohorts using both structured and unstructured data, as I mentioned. And now this is where we've got to the point where we can enable an OMOP integration. In the research, which is what's to come, and this will be the integration of how the OMOP will work, which I'll show you in a moment. So what you can see here is you've got our IEMR system as one of the data systems, and clearly there'll be other data systems that will also come online and be made available. And here we've got our Quiet system, which does the data integration. It does the data integration into, we'll be able to do this into an OMOP database. So it describes what data we want and how we're going to select it from here. But it also tracks all the way back, remember, to our data definitions, so that we've got full data lineage as to what each and every one of those fields means, where it comes from and where it comes from. And obviously you can see that we could create data model extensions as well. And then the future really is the next step, which is about working out how to make these outcomes feed back into our system. So, and this really is the future, about creating reusable building blocks, so task-oriented clinical deep learning or machine learning models, so to enable clinicians and other researchers to test new hypotheses, but perhaps with existing models that already exist, without having to start from scratch each time or make it a custom build. We want to monitor, we also want to monitor the model performance with live data. So once you've made a model, you've made it, generally speaking, out of existing data that's fixed. And what you'd really like to do is monitor it in a live manner with live data that's coming through, so that you can check that over the coming months to see its reliability and also how accurate, whether its accuracy is maintained. And then, of course, once you select a model, you want to reintegrate it back into the data products within Queensland Health. So you want to put it onto dashboards, for example, and you may use different protocols such as FHIR. So this is really the future. Okay, that's the end of my presentation. I'm very happy to take any questions, and I believe that Claire Sullivan is also on the line. And I think Claire will also help out with any questions, especially if they're of a clinical nature. Thanks.
Thank you. Wonderful presentation. Anyone got any questions? Oh, I have one. So on your, if you can go back one slide. So why is it that, actually one more, sorry. Why is it that you guys have chosen to like pick out the cohorts inside your IEMR first and then do the integration to OMOP? Why not just take the whole thing and then integrate it into OMOP?
Yeah, that's a good question. So probably the main reason around that is that OMOP has a defined structure, and you'll have to correct me, I'm not an expert on OMOP. OMOP generally has a defined structure, and the first thing when we talked about OMOP to some of the clinicians is, oh, well, you know, there might be other information that we want to collect, other cohorts, different cohorts that don't fit in that mold, different variables, etc. And within the healthcare organisation itself, you could also see that there may be things that sit well outside of those data models. So in this way, I guess what it allows us to do is a byproduct of having our system is that we can identify the variables and that are required for OMOP, and therefore the extractions. So that's great. So they can be produced and then they can be used, but also anything that doesn't fit into that nice model, we can still define it. It's not going to go here, but it will still be used within the healthcare organisation for other purposes.
Okay, that makes sense. So how long has this project been going on that you guys have been using this process?
Yep. So we just started the project, and Power started last August. So we haven't been going a year yet, and we've designed the first part of Quiet, and this second part now is nearly finished. So it's very much an underway project, not a completed project.
Oh no, that's great. No, that's great to hear that. You know, I'm sure when you guys are done, we would love for you guys to come back and tell us how, you know, how you guys are using it and what pros and cons you find with using this, right?
Yeah, absolutely. And that's, of course, you know, where the rubber hits the road, and we'll find out how it works and what problems we've had and all the rest of it. Absolutely. So I appreciate that, and we'd love to do that.
Awesome. Anyone else have any questions or comments?
Hi, can you hear me?
Yes.
Hi, it's Ezra Fass. This is kind of the other side of the coin of your question, I guess, and it's more maybe an OMOP question. But I mean, I guess what's really nice about the system that's was just presented, and thank you for the presentation, is that, you know, there's somewhere to kind of expose the variable definitions and all that source information to the user. Let's say if you did do, as you had suggested, Moy, kind of map everything into OMOP first, is there an equivalent? I'm not familiar. So is there a way or a tool or something that kind of shows that information and definition information within the OHDSI framework to an end user, or is that something that's available?
So in the OHDSI world, we have the CDM, right? So if you map everything over, I can tell you based on a lot of experience, you know, you can have your source. So in this way, right, you're only mapping over what you need, versus what you can have is over where he has the various data. He can have the source EMR, right, the source one, and then source one OMOP, right? Because then everything's already in OMOP. And but you know what fields you have in OMOP versus what fields you don't have in OMOP. So then your cohort selection is a lot easier that way, right? Because you're only doing the conversion once. You don't have to constantly, after you move everything over, do the conversion over and over and over again, right? That's the reason why we asked why not do it once? Why do it after you slice? Now, so there are pros and cons there, because the slicing of the cohort, they're smaller, right? So your conversion is going to be smaller from that point of view. Versus the one-time thing, you have to spend a lot more time up front, right? It's more of, well, how much time you want to spend up front versus how much time you want to spend in the end portion of it, right? So those are some of the differences. I mean, within our group, we choose to do the upfront, and then, and you know, this is being recorded, so hopefully none of the global gods are going to come over and smack me for saying this. But people, you know, how to deal with the things that OMOP doesn't cover, right?
Yep.
You can have external tables.
Mm-hmm.
That still links to the your
Right.
OMOP data, right? You can have other tables in your model that aren't standardized. But here you have your standardized one, right?
Yep.
And then you have the non-standardized one down, in the same environment, but they're just linked. And I've seen a lot of people do that, right? Because like you said, OMOP doesn't cover every single case. We're not going to. That isn't our purpose, right?
Yeah.
So you can do that, and then it's one database.
Yep.
Yeah. So
thanks so much. Yeah.
That's kind of how I've seen a lot of people do it, including ourselves.
Thank you.
I just have a column or two. I don't have whole tables. I have a column or two that I have on the side.
We won't mention.
Hi, I have one question.
Yes, go ahead.
Yeah, I think I can see you extract specific cohort from multiple source of database. So then after that, you integrate them and you convert to the OMOP CDM. Then my question is, how will you process the duplicated patients? Do you have the patient's ID or any specific methodology for processing the duplicated patients?
Okay, so at the moment, those cohorts are only deriving from one system, and we already have an anonymized system that's set up, so that in order to generate something like the common data model, like an OMOP database, we would tend to use that so that there's no issue regarding any patient information being released. But once again, that in order to do that would still require going through full ethics approval and etc. So yeah, I hope that's answered your question.
Okay.
Awesome. Any other questions?
Yeah, I've got a quick one, if that's okay.
Yep, go ahead.
Hi, it's Nicole here from University of South Australia. This is awesome work. Thanks so much for presenting it. I just had a quick question, and I guess a bit of a shout out as well around what you talked about around building an evidence or building a library of predictive models. So you talked about having models built in the data and having them available for reuse by the doctor or by a clinician, that kind of thing within your system. That's something that the OHDSI community, I think, are also very interested in doing. And yesterday we had a presentation by Ross Williams, who works with the patient level prediction group, and Jenna Reps, and what they're trying to do is do that exact same thing, so build a library of predictive models that are available for validation in other databases that have, been OMOP'd. So I think there's a lot of synergies there with what's going on with the community, and it would just be great to sort of get you involved in work as well and learn from what you guys are doing in that space. So.
Thanks, Nicole. Actually, I mean, as I said, that's very much future work, and it's something we wanted. And I think it'd be great to plug into that if you've already walked down that path a little way. We've really just done investigations and sort of found some other, on a global scale, sort of done a search and just found some other examples, but there aren't many where people have actually been able to do that. So if you've got a group who are working on that, even though it focuses solely on OMOP, I think that would be very interesting. And I'd love to get in touch with them.
Oh, great. I'll be in touch with you after this and we can sort of sort something out.
Great. Thank you.
Great.
Any other questions from anyone? Thank you very much for the presentation. Well received, wonderful information, and great work.
Thanks for your time. I appreciate it. Thank you.
Now, on that note of what Nicole just said, the one OHDSI update that I did miss was